All right, so we're starting chapter 1. Let's go over some terminology. What are some words that we use for addition? Yes, some. Good. What else? For addition. Yep. Plus. What else? Yep.
Equals.
For addition. Yeah.
Combine.
Combine. Good. Okay. Okay. Or even just simply add. Okay. That's good. What about subtraction? Andy?
Take away.
Take away. Good. Tayden? Minus. One more. Yep. Subtract. And the more important one. There's one that we. Oh, actually, yeah, that's a good one. Less. Difference. That's right. Difference. All right. Multiplication. Hayden? Times. Yep. Yep. Product. Yes, that's a key one. Is there more? Sorry? Multiply by. Okay. Or multiplication. Yep. Division. Yeah. Numerator, denominator, fraction. Yeah. So fraction is a type of division. There's if this multiplication is product, what is the one for division? Starts with a Q. Quotient, right? Quotient. Okay, and then the others, for example, in a word problem, is means what? William, what is equal, right? So is means equal. Okay, we also have the greater than or less than. Okay. Okay. These words right here will help you build the equation. Okay. So as I was saying, we know how to write one equation. We know how to graph one line. So a linear system is basically two lines. Okay. And so I was saying, if you know how to draw one line, do you know how to draw two lines separately? Yep. And when two lines cross, you're going to get a point of intersection. So the point in XY form, in coordinate form, where the two lines crosses.
Everyone okay?
In this case, what's my point of intersection here? William? 2, 2. And any coordinate, we have to write it in brackets with a comma in between. Okay. Will two lines always have a point of intersection?
No.
What type of lines won't have? Gavin?
Parallel.
Parallel lines, right. Parallel lines, they never cross, so you don't have a point of intersection. Let me ask one more tricky question. What if the two lines are on top of each other? Where is their point of intersection? Gavin?
When you say on top of each other,
Yeah, so like let's say I graphed this line and then I graph a second line that is right on top of it.
zero.
Right. William?
Everywhere.
Everywhere, right. So you actually have infinite number of point of intersection. Good job. Yep. We'll get more into it. I just wanted to get that in your head first. But later on, we'll have a proper lesson on that, on the number of intersection points. Okay, so let's try example 1 right here. Who has a beautiful voice? Okay, thank you. Tata, can you read example 1 for us?
services after money. Charges $10 per hour. Adds RS delivery service charges $120 for the season.
Thank you. And then A, write an equation for the amount Sarah charged to deliver for the flyers for the season. Okay. So so this one she charges $10 per hour. So I want to write an equation. Again, what is the format of an equation? Equation of a line. What's the format? Yeah. Y equals mx plus b. So we want to write it in y equals mx plus b format. So $10 per hour. So y equal
$10 X.
Yeah, 10x. That's it. Okay. My B is 0 because I'm not charging anything extra. It's just the $10 per hour. And so that's my equation. Okay, what about ATS-RS? ATS-RS is just the 120 for the whole season, no matter how many hours. So what would my equation be?
Y equals 120.
Y equals 120. Good. Okay. Where's the X? Where's the M? Well, because it doesn't matter how many hours I deliver. It's just I don't have that part. It's just the 120 flat. Okay, I only have the flat rate. Okay. And so now that we have two equations, what is the intersection point of these two linear equations? Okay. So if I'm saying y equals this and y also equals this, then I can substitute. I can replace this y right here with 120 equals 10x. Right? Do you see how I just put this into this equation right here? So this is my first equation. This is my second equation. And I'm replacing this y right here with the 120 because that's what you told me y is. Okay. So how do I solve for x now? You should know this because we just had a test on this. Adam?
120 by 10.
Right, yeah, divide. So simply just divide it by 10. So I get 12 is x. Okay. Will I get full marks if I just write this? No. What should my answer be?
Brackets 12, 120.
Right. Okay, it's asking you for a point. So my answer is 12 and 120 as a coordinate. Okay, good job. So in the context of this question, what does the point of intersection represent? What does the 12 represent? What does the 120 represent? Andy?
Doesn't it represent like when the two costs become equal?
Yep. And so what does the 12 represent? What does the 120 represent?
It represents like
12 what?
hold on.
Hours.
Yeah.
Good. Okay, so 12 hours. And what does the 120 represent? Yeah.
Sorry, excuse me.
What's my unit for that? Gavin?
Like just the fixed cost.
The cost, right. So at 12 hours, both charges $120. Okay? Remember, this is a point of intersection. So it means if I just deliver the flyers for at $10 per hour, after 12 hours, it's going to cost 120. Now, if I were to go with ATS-RS, it's just 120 for the season. So you see how the two companies or the two different scenarios will meet up both at this point. Right? Both charges $120. Okay. You will see this question on the test where it says, in the context of the question, what does the point of intersection represent? And no matter how many times I say it, in the context of the question, people tell me is where the 2 points meet. Okay. I'm not asking you to define point of intersection. I want to know if you know what you were solving for. Okay? Let's try this next one. Hey. So find the point of intersection by graphing. So that's what 1.1 is about. 1.1 is solving it by doing graphs. Okay? So method 1, we're going to use y equals mx plus b. You guys just had a whole test on this, so you should be experts at this now. So x plus y equals 6. Rearranging this equation, y equals what? Perfect. Okay. So what's my m and what's my b? My slope is negative x. Negative 1. That's right. Negative 1. And my b is 6. So when I graph this, 6. 1, 2, 3, 4, 5, 6. Okay, I have my y-intercept at 6 right here. And my slope is negative 1. So what do I do? Yep. Yep. So should I go up or down? Down. Down 1 over 1. Down 1 over 1. Down 1 over 1. I can do this all day. Okay. Keep going, keep going, keep going. Looks like that. Okay. For this unit, it will be a good idea to have a ruler because you're looking for the intersection point, and if your line is not accurate, it is not going to give you an accurate point of intersection. Okay. Second equation. 2x minus y equals 6. Okay. And it will help if you have two different colors as well. Okay. Let's see. Rasman, can you help me with this one? Rearranging it. Perfect. Okay, but I don't want negative y. I just want positive y. So what do I do with that negative? Yeah, right, because it's like you're dividing everything by negative 1. So then you get y equal positive 2x minus 6. Good. Okay, so in this case, let's see, who should I ask? Sydney, what's my slope? What's my y-intercept? Perfect. So negative 6 here. So 1, 2, 3, 4, 5, 6. Okay, I have my y-intercept at negative 6. And then from this point, Nelia, rise over run. So I go up and over. Perfect. All right, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay. Okay. And I answered the question? No. What is my answer? Gavin.
You have to like take the point of intersection.
Right. Again, it's looking for the point of intersection. So I have to answer the question. This is all beautiful work, but I haven't answered the question. Okay. And what is the answer then? Gavin?
X4 and then Y2.
Perfect. So this point right here, the point of intersection, 4 and 2. All right. Not 2, 4. Remember, X always comes before Y. So it's your X coordinate and then your Y coordinate. So 4, 2. Okay. How do I check if my answer is correct? Right, yeah. So if I'm saying right here, X is 4, Y is 2. What's 4 plus 2? 6. Yay. Okay, and then 2 times 4 minus 2? 6. Okay. So if your point of intersection is correct, it should satisfy both equations. It should work. If not, then you made a mistake. Okay, last example right here. Find the point of intersection using intercepts. Okay, so first equation, x minus y equals 3. Okay, so, and that's why we've been doing the recap. To find the x-intercept, what do I let y be? 0. Yeah, that y equals 0. Okay, so x minus 0 equals 3. I'm replacing the y with a 0 right here. Okay, so then x is 3. Okay, what's my coordinate here? 3, 0. Right? And then to find the y-intercept, to find the y-intercept, I let x equals 0. So 0 minus y equals 3. So what is y? Jaden? Negative 3, right? So my other point on this red line is 0, negative 3. Okay, so let's plot this point. Let's plot this line. So 3 and 0 right here, 0, negative 3 right here. I have the 2 points, so I can draw my line. Remember, you need 2 points to draw a line. Okay. Can you guys try this right now for the second equation? Do the same thing. 3x plus y equals 5. Alright, so find the x-intercept, find the y-intercept. Find y-intercept. Okay. Do the exact same thing. Try it